Here we go. Now, let's look at the simplest type of circuit that we can draw. This is going to be a series circuit. We're going to have a voltage source, and I'm going to put 3 resistors in the circuit. And we're going to label this V for the potential difference, the battery, the voltage source. The long end is always positive, the short end is always negative. And in conventional terms, this is called conventional current. We basically say that the positive charges flow out of the positive end of the battery and flow to the negative end of the battery. That's not what actually happens. What actually happens is that the electrons are moving, the negative charges are flowing out and going to the positive end of the battery. But by convention, a long time ago, they thought that the positive charges were moving, so they chose that by convention, and that's how it's been ever since. So we just haven't changed it. We're going to call this R1. We'll call this R2. We'll call this R3. So that's resistor 1, resistor 2, resistor 3. The same current flows through all 3 resistors, so the current is constant in the circuit, but the voltage is not. The voltage that the battery supplies is constant, but there's a voltage drop across each resistor that depends upon the value of the resistor. We're going to look at Ohm's law, V equals IR. So V1 is equal to IR1. That's the voltage drop across the first resistor. V2 is IR2. That's the voltage drop across the second resistor. V3 is IR3. That's the voltage drop across the third. The total voltage, VT, is equal to V1 plus V2 plus V3, and that's equal to IR1 plus IR2 plus IR3. We're going to bring this down, get rid of that, and just say that total voltage is equal to IR1 plus IR2 plus IR3. We're going to factor out current and put the resistors in a set of parentheses. Voltage total is equal to current times R1 plus R2 plus R3. And now what we can do is this. We can say that if we wanted to replace all 3 resistors with one resistor, we call that the equivalent resistance. So Req is equal to R1 plus R2 plus R3. And now we have voltage total is equal to IREQ. So when you're solving for current, you can take the total voltage and divide it by the equivalent resistance. Now this derivation gives us the equivalent resistance for a series circuit, and it just happens that it doesn't matter how many resistors you have. If you have 2 resistors, you can use Req equals R1 plus R2. If you have 4 resistors, Req equals R1 plus R2 plus R3 plus R4. So how many ever resistors you have, you just keep adding. So in a series circuit, add up the value of the resistors, and just as an aside, the unit for resistance is the ohm. If you add them, you get the equivalent resistance. And again, that is the value of one resistor to replace all the resistors in the circuit.